Good evening, everyone. I hope I'm audible. Please write on the chat if I'm audible. Okay. So, thank you. So, I welcome you all to the 10th day of our training, machine learning using Python. So, we'll wait for 2 more minutes so that all the participants can join. And you also tell your colleagues and friends, remind them to join as soon as possible so that they don't miss anything. Okay. Meanwhile, if you have any questions, any queries, you can ask me. Yes, good evening, good evening, good evening. Regarding exam, tomorrow there will be a quiz. MCQ question will be there, 15 to 20 question will be there. Regarding whatever we have done in the last 10 days, in the last 2 weeks. Okay. Data link on the WhatsApp. Okay. Just a minute. Time of exam will be after the session. And tomorrow I'll take 1 hour before. Session will be 1 hour before. So tomorrow the session will be not very much longer. It will be hardly 1 hour. Okay. And the remaining half an hour will be the quiz one. Okay. Okay, so I provided the data set. You can check. Okay. Yeah. Tomorrow I'll take it from 6 o'clock. Yes. I'll inform that in the WhatsApp group. Okay. And at the end I'll discuss this. So now let's start today's session. So once again, good evening to everyone. So today is our 10th day, and in the last 9 days we discussed so many things, and I hope you all are clear with all the topics that we have done in the last 9 days. Okay, now today what we are going to discuss, it is related to the unsupervised learning. Now in the last class, in the last sessions, we have discussed some algorithms, 2 3 algorithms that was a part of unsupervised learning, right? So today whatever we are going to discuss, it is a part of unsupervised learning. And I hope you remember what is unsupervised learning. Unsupervised learning is that kind of learning which we apply to the, anybody can tell me what is unsupervised learning? What is unsupervised learning? Unlabeled data prediction. That means the data is not labeled. We don't know the output. There is no labeling. There is no Y value. Correct. Unsupervised learning. Okay. So no labeling of data. No labeling of data. Okay. That means the output is unknown. The output is unknown. Okay. Now, for applying this unsupervised learning, we have so many techniques. Like here, if you remember, I told you that here we have a concept of clustering. We have a concept of clustering where we make different cluster based on the similarities. Okay, based on the similarities. So today I am going to discuss two algorithms. We have so many algorithms related to this, but I will discuss only two algorithms. One is your k-means clustering, and another one is your hierarchical clustering. These are the two very much famous clustering that we have in the unsupervised learning. So I'm going to explain these two clustering today, and we'll perform the practical also on this. So these are the two things that we are going to discuss today. Okay. So first of all, let me explain the k-means clustering. Okay. Now, what do we have in k-means clustering? Let's. Are you all not able to get my data set? You all are sending the access? Just confirm this. Yeah. No access. Okay, wait. Just a minute. Okay, now everyone can check. Now click on the link and tell me, are you getting the data set or not? Just check it now. I have updated the, I've given the access now. Check it now. Click on the link again. Okay, fine. Okay. Now, let's assume that, let me take this. Okay, let's assume that these are my some data points. Okay, they are my some data points. Okay, let's remove this. Okay, like this we have some data points. Okay, now what we want is, we don't know level, we don't have anything here. I want to cluster this, I want to group this according to the similarities or according to the nearest distance. So what we do actually in this, first of all, we decide the value of k. We decide the k value. Okay, that how much k value you want. And this k value is hit and trial. In the practical, I will tell you how to decide this k value. That I will tell you during the practical. Okay. So right now, let's assume that I am taking the k value as 2. So if I'm assuming that k value is 2, it means that I want 2 cluster. I want to make 2 cluster. That's the meaning of this. So 2 means 2 cluster, and also 2 means 2 centroid. There will be 2 centroids also, 1 centroid for each cluster. Okay, so now what it will do is it will plot 2 random point on that graph, or in the plane we can say 2 random points will be plotted. So let's say this is one random point, and let's say this is another random point. Now these are my 2 centroid. Initially these are my 2 centroid. Anywhere it can be plotted, anywhere randomly. Okay, now after this plotting is done, now the distance from the centroid to each point will be calculated. All the points will be calculated, the distance. So if, let's say, if this point is near to this point, if this point is near to this point, so I can say that it belongs to this cluster. Okay, so if, let's say, this point is more near to this point rather than this point, so I can say that this belongs to this cluster. Okay, so like this, based on the distance, based on the nearest distance, we the points will be grouped into different cluster. Okay, now there is one more way. We draw up line which connect these 2 centroid. Let's say this is the line which connect the 2 centroid. Okay, this is a line which connect the 2 centroid. So we can also do that one thing, that there is one perpendicular line drawn here. There is one perpendicular line drawn here like this. Okay, and this perpendicular line, whatever sample we have before this perpendicular line, it will be considered as the green samples, and whatever sample we have after this perpendicular line this side, we'll consider it as a red sample. So this can also be done. Okay, so this is how the samples are clustered. Now when this is done, this is only done in the first iteration. In the first iteration, it will see the nearest point and group all the points into 2 different clusters. So let's assume that this is my 2 cluster. This is these are all my green points. Okay, now these are my red points. These are my red points, let's say, and this was my centroid. Let's assume that this was my centroid. This was my centroid. So this is to be done in the first iteration. This is to be done in the first iteration. Now just hold on for 2 minutes. Okay, fine. Now, no, not randomly. It is basically in the center of this line. I've taken here. It is basically in the center of this this line connecting here, in the center. Okay. Now after this, in the second iteration, the centroid will be updated. In the second iteration, the centroid will be updated. Now how it is updated? What it will do, it will take the average of all the points. It will take the average of all the points in the first cluster. It will take the average of all the point in the second cluster. So let's say after taking the average, my centroid of this cluster shift here, let's say, or let's say it shift to here, let's say. Okay, and the centroid of the another cluster shift here, or wait, let me draw another line, another image. It will be more better. Okay, so now another, let's say these are my green samples right now. and these are my red samples right now. Okay, now let's say in the second iteration, the centroid is now updated. Updated means it will change from here to, let's say, here. This is my new centroid. Let's say this is my new centroid of this cluster, and this is my new centroid of this cluster. Now again there will be one perpendicular line like this. First of all, it will draw this line, and then again there will be one perpendicular line like this. Now tell me, in this iteration, there will be any change in the points, grouping of point? Will there be any change in this iteration? If you see, these 2 points will be updated, right? These 2 points will be now belonging to the green cluster. Am I right? So, done. Now in the third iteration, again average will be taken, again centroid will be changed, and again the thing will be done. So this iteration, this step will be repeated till there is no change in the clustering point. Till there is no change in the clustering point. Let's say finally you got this cluster anywhere, this centroid anywhere, and after taking that centroid, there was no change in the data point. The data point was as it is. So that will be the final iteration, and that will be the final clustering. So am I clear how k-means clustering work? Tell me, everyone. Is that clear to all how k-means clustering work? Okay. Now, when you work with a real data in an industrial, for any industries or for any companies, there you may not have 2 dimension only. You may have so many features. So it will be very difficult for you to plot that feature on the graph. No, I just told you it is not random. It is in the center of this connected line. Center of this connected line. Okay. So in the real time, when you are working with a big data, there may be so many features. So it will be very difficult for you to plot all the features on a graph, because we can plot only 2-dimensional data or maximum 3-dimensional data. We cannot plot multi-dimensional data like 5-dimensional, 6-dimensional. We cannot plot that. So in that case, we use elbow method to find out the k value. We use elbow method. Elbow method to find out the k value. To find out the k value. Now, what is that elbow method? Now, what actually it does, it calculates the sum of square for each cluster. Sum of squared error for each cluster. Let's say this cluster for each cluster. Okay, so for each cluster. Now what is the formula of sum of squared error? So let me tell you the formula for that. Okay, sum of squared error, SSE equal to it is not equal to 0 to n. Okay, distance of xi minus ci ka whole square, where x is your data point. Okay, x is your data point and c is your centroid. That means we are calculating the distance of the data point from the centroid, and then we are squaring it. And why we are squaring? Just to remove the negative values. That's why we are squaring only. Okay. So this is the sum of squared error that you will be getting for the overall clustering. That means this will be done for each cluster. SSE1 plus SSE2 and like this and so on for each cluster. Okay. So now after calculating this sum of squared error, it will be plotted on the graph. Okay. So let's say that this is your K value. This is your K value and this is your sum of squared SSE. Okay. So let's say for K value, let's say this is your 2, this is your 3, this is your 4, this is your 5, 6 and 7, so on. Okay. And the maximum K value can be the number of samples. Yeah. It can use Euclidean, you can use Manhattan, any distance you can use. Okay, any distance. So now let's say that after plotting, now we'll plot this. So let's say if I'm taking the K value, the sum of squared is this. If I'm taking the K value, the sum of square is this. Like this, I am getting the points. Like this. Now, if I draw this line here, so you'll see that there is a abrupt change here. Like after this point, it becomes constant or something like this. So is it not looking like an elbow? Tell me. Is it not looking like an elbow? Just a minute. Wait, just hold on. Okay, yeah. No, actually I am muted myself. There was some important thing. Okay, so now this is an elbow, right? So through this elbow, you can decide the K value. So you should take the K value as 5. So wherever your elbow will be coming, you can take that K value as the final K value. So this is how you apply K-means clustering. K-means clustering. Okay, so I hope this is clear to everyone. Please confirm this. K-means clustering is clear. Yeah, K-means clustering is clear. Okay. Now coming to the next one, which is your hierarchical clustering. Now this is a time-taking process. Remember this. It will take more time as compared to the K-means clustering. Okay, it will take more time as compared to the K-means clustering. And why it will take time, that I'll explain after some time. Okay. Now here we have two types of hierarchical clustering. The first type is agglomerative clustering, and second one is divisive clustering. Now out of these two, we mostly use agglomerative clustering for the industries. I'll tell you the reason after completing this, why we use this. Okay. Yeah, by this K value, you will get the better accuracy. Yes. Okay. Better cluster, you can say. Don't say accuracy, because here there is no meaning of accuracy. Don't say accuracy. We can say better clusters. Okay. Because we don't know the labeling of data, so we cannot calculate accuracy here. Okay. So now, what are these two types of clustering? Let me explain that to you. So let's assume that these are my data points. Again, I'll take some data points. Okay. So let's say A, B, C, D, E. Let's say these are my 5 data points. I'll take an example of only 5 data points. So I'm having total 5 data points here. Okay. And I want to apply hierarchical clustering to this data, Okay. So first of all, I'm going to explain agglomerative clustering to you. Agglomerative. So I'm going to explain the agglomerative. Now this is basically known as bottom to top approach. I'll tell you why we call this as a bottom to top approach. Bottom, basically here we move from bottom to top. Okay. Now, what actually we have here? Now here, there is something here, linkage function. Linkage function. This is the simple mathematical function which helps the model to decide which point we should take in one cluster. Either we should take A and B together, or I should take A and C together, or I should take B and C together, or I should take B and D together. So through the linkage function, it helps the model to decide which point we should cluster. So we have a different types of linkage. Like we have a single linkage. Okay. Single linkage. We have complete linkage. We have average linkage. We have word linkage. There are some different types of linkage that we have. Single, complete, average, word. If I'll get time today at the end, I'll explain about these linkage, what are actually linkage. Okay. So right now, just understand these are some mathematical equations, some mathematical formulas. Like here we consider the minimum value, here we consider the maximum value, here we consider the average value, and here we consider the minimum cost function. Minimum, you can say errors, you can say minimum cost function or minimum variance, you can say. So through this function, it will decide which point to be clustered, which point to be grouped in a single cluster. Okay. Now, no centroid will change. No, in the first one, after the cluster is final, the centroid will not change. No? When the cluster is final, when the Y centroid will change. Centroid will be same actually. Yes, correct. CI represents centroid of first cluster, then second cluster, third cluster. That's the meaning of CI. Okay. Now, okay. So now what this agglomerative will do here in this case? Here it is going to make, or I can say draw, dendrogram, and through dendrogram you decide the number of cluster. And how many cluster we should take. So we basically draw dendrogram using agglomerative. So now what is this dendrogram? Let's plot and let's understand. Let's suppose that in the first iteration, now what actually this agglomerate do? In the first iteration, it will assume all data point as one cluster, sorry, as independent cluster. That means if you have 5 data points, it will consider 5 cluster. It will make 5 cluster. Okay. So let's say that you have 5 cluster here. Cluster A, cluster B, cluster C, cluster D, and cluster E. So I am having total 5 cluster here independently. They are totally separate. Okay. So we are assuming that all of the data points belongs to 5 different cluster, independent. Now in the second iteration, it will ask the linkage function, can I merge A and B? Can I merge A and C? Can I merge A and D? Can I merge A and E? Or can I merge B and C? Like this. So let's say the linkage function is saying that, okay, you can merge A and B because A and B are very near to each other. Okay, so in the second iteration, what it will do, it will make this A and B as one cluster, and the remaining will be the different cluster. So now tell me, here you have total 5 cluster in the first iteration. In the second iteration, how many cluster will be there? In the second iteration, how many cluster is there now? Count it and tell me. How many clusters are there now? 4 cluster. Yeah, good. 4. So this iteration will go on till you get 1 cluster. Till you get 1 cluster. So now in the third iteration, it will again ask the linkage function, can we merge any other cluster? Can we merge any other cluster? So let's say the linkage function will say, yeah, you can merge C and D because C and D are very near, let's say. So let's say I will say that C and D can be merged. So like this. So we merge C and D. So now in the third iteration, how many cluster will be there? 3 cluster. This is 1 cluster. This is another cluster. And this is another cluster. So we have total 3 cluster now in the third iteration. Now in the fourth iteration, again it will ask, can we merge some more cluster? So okay, he will say that yes, E is near to C and D. The E point is near to C and D. So you can merge C, D and E. So I can say that I can merge C, D and E like this. So now how many clusters are left? This is 1 cluster, A and B, and C, D and E is another cluster. So you have now 2 cluster. And finally in the 5th iteration, it will ask, can I merge all the cluster? So yeah, okay, he'll say yes, you can merge. So I have merged all the cluster. That means now I will have only 1 cluster left. So now the iteration will stop. So this is your dendrogram. This is your dendrogram. Now here, if you have seen, we moved from bottom to top. Am I right? Tell me. Bottom to top. And that is why we call this as a bottom to top approach. Bottom to top approach. So tell me, is that thing clear to everyone? How the dendrogram is plotted? Tell me. So initially it will start with all the individual cluster, and finally at the end it will make all the data point in single cluster. And now after getting this dendrogram, you have to draw the horizontal lines like this. Like, not you have to draw it in the graph, like in your mind you have to draw the lines like this. Let's say the line I'm drawing here. Okay. What is liking? Okay. Horizontal line I'm drawing here. Okay. Let's say this is one horizontal line I'm drawing here. This is one horizontal line I'm drawing here. Now after drawing the horizontal line, now just tell me which is the longest vertical line, the longest or the largest vertical line that you can see here. The largest vertical line I'm asking, vertical line. Can I say this one? Just tell me yes or no. Can I say this line? This line as the longest line. Can I say that? Yeah, this one, right? So if you consider this line as the longest line, so now look here, if you are drawing horizontal points, how many points it is cutting there? How many points it is crossing? So see here, it is crossing here 2 points, but here it is crossing 3 points. Here it is crossing 3 points. That means we don't have to consider this one. We don't have to consider this line, because we should take the minimum one which crosses the minimum number of points. But here I can see that this line is crossing. If you see here it is crossing 4 points, 1, 2, 3, and 4. So we cannot consider this line as the longest line. Now tell me, if I consider this line as the longest line, this line. So in that case, how many data points are cutting if I'm drawing horizontally? Only 2. Only this and this, right? So I can consider this as my data point. So we have how many cluster here? How many cluster you can see here? One cluster here and another cluster here. In between this line, how many cluster I can see? Here is one cluster and here is one cluster. So total 3 cluster I can see here. So I can say that K value can be 3. So in between that line, how many cluster you can see, that will be the K value. K value or number of cluster you can say. Number of cluster can be 3. That means we can take the number of cluster as 3. But this trick, this is not a rule that I am telling you. This is just a trick that we use in most of the case. In some case, it may give you the wrong cluster. So you just have to try 2, 3 and something like that. It may give you the wrong, but in most of the case, this trick work. Okay. So this is a trick that we use. This is not a rule. This is a trick that we use to find out the number of cluster. Okay. See, Vibhuti, if you see this line, I'm talking about this vertical line. So till this line, I can draw only this horizontal line. So this horizontal line is crossing here and crossing here. That means in between this line, how many cluster you can see here? This is one cluster here. This is another cluster here, 2 cluster. And this is another cluster here, 3 cluster. So I'm having total 3 cluster in between this line. So I can say that the number of cluster can be 3. The good number of cluster can be 3, where you can get the good cluster. So this is how we apply hierarchical clustering. So it's like an hierarchy, right? It's like an hierarchy. So this is your agglomerative clustering, which we use in most of the case. Now let me tell you about the divisive. Divisive is very simple. It will hardly take 2 minutes. Divisive. Now this we generally don't use. I'll tell you the reason why we don't use. Divisive clustering is basically the top to bottom approach. Top to bottom approach. Top to bottom approach. Now here, initially in the first iteration, we assume all the data point in a single cluster. A, B, C, D, E. In the agglomerative, we assumed all as a different cluster. But here initially we assumed all the data point in a single cluster. Now in the second iteration, we'll again ask linkage function. Can I separate A, B? So like, let's say it is saying that, okay, you can separate A and B. So A and B I can keep in one cluster, and I can keep C, D and E in one cluster. Further, I can say that I can keep C and D in one cluster. I can keep E in one cluster. So we are going here top to bottom. So this is your divisive clustering. Now, why we don't use in most of the application? Like, let's take an example of any e-commerce website, Flipkart, Amazon. Let's say Flipkart is having the customer data, and he want to cluster the customer according to the demand, wish that what he can purchase, what is the customer taste and something like that. Let's say now there is one case. The first case, Flipkart is assuming all the customer is having the same taste. That means they can buy the same type of product. And in the second scenario, he is assuming that all the customer are of different taste, that they can buy a different product. So tell me, which one is the correct assumption? We assume all the customer same, or we assume all the customer as different? Tell me. Right now, let's say you all are around 80 people, 85 people are watching here. If I assume all of you are the same property, or if I assume all of you are a different property, which one will be better? Different one, right? We should assume different one first, and then we should filter out, right? So that is the basic assumption that we should take. So in the divisive, it is assuming all of these in a single cluster first of all, and then it is dividing. But in the agglomerative, initially it is assuming all as a different cluster, and then it is grouping into different cluster. That is why we use agglomerative in most of the case. So this was all about the clustering, that how we can apply clustering to your data. Now we'll understand this thing in practical. So let's do it practically and understand this practically. Now everyone present here, hit the like button, click on the thumbs up icon, hit the like button, all of you. You can see only 51 likes till now. Okay. So just tell me one, first of all, have you all downloaded the data set? I have shared one data set file with you. Have you all downloaded a data set? Right now it became 66. Initially that was 51. Okay, fine. So I have provided the collab link, I think, on the chat already. Yeah, already there is a collab link on the chat. You can take it from there. Okay. So now let's apply this. So first of all, we are going to apply the k-means clustering. Okay, I'm going to make the cluster on the basis of by the use of k-means. We'll do the k-means first, and then we'll do the hierarchical, and we'll use the same data set in both practical. Okay. Later on, you can change the data set and you can try different data set. Okay. So I'll import the data set first. So let me upload it first here. Income.csv. Copy path. So import pandas as PD. Let's import matplotlib also. Matplotlib.pyplot as plt. Okay. Now data is equal to pd.read underscore csv, and here I'll pass my dataset link. I've already provided in the WhatsApp group, and just open the collab link here. Also, you'll get the dataset link. Okay. You should check the group also now. Why I have made the group? You should check the message in the group also now. Okay. So this is the data set that I'm having here: name, age, and income. Okay. Just three things I'm having here. So obviously I cannot use name for the cluster. We'll just use age and name only. Age and income only. Name cannot be used because name is a string data. So we'll ignore the name part. So we will use only the age and income. So first of all, let's plot these two features on the graph. And let's see how many cluster we can make by just looking at the graph without the elbow method. Later on, we'll see the elbow method. Right now, let us decide the number of cluster by just looking at the graph. So plt.scatter. So I'll pass here data of age, comma, data of income. Okay. So income dollar. So I'm plotting age versus income. Okay. You can give the label X, label age, and plt.y label income. Plt.show. Let me increase the size of the data point. S is equal to 100. Okay. So now look at the graph and tell me what should be the K value that we should take here. Tell me. How many clusters we should make here just by looking at the data point? What can you say about this? What should be the proper K value? Yeah, 3. Correct. 3. I can see that 3 data, right? 3 separate data points. So I can say that K can be 3, but we will verify this using elbow method also. Okay. Using elbow method also, we'll verify this. So what I'll do is we'll assume that K value as 3. So let's make the model and let's apply the clustering and let's draw the clustering. So I'll write here from sklearn.cluster import k-means. Import k-means. Okay. From sklearn.cluster import k-means. And now, now after doing this, we'll make a model here. So let's say km is equal to k-means, and I forgot to take here K capital. Okay. Now in the bracket, we have to pass how many cluster you want. So let's say I'll pass here n underscore clusters equal to 3. N underscore clusters equal to 3. Now we will predict our output. We will get our prediction. So if we have 3 cluster, I will get 0, 1 and 2. 0, 1 and 2 because 3 clusters. So it starts from 0. So ypred will be km dot fit underscore predict. Fit underscore predict is a function to predict the cluster, and here I'll pass data of age, and it should be in the form of data frame. Let me do one thing to make it simple. I'll write here x is equal to data of age, comma, income. Okay, I'll just separate these two columns inside. Oh, sorry. Income not in index. Oh, I missed the bracket. Okay, so these two columns I have separated that. Okay, and now directly I'll pass here x. Okay, I'll pass here x. Now if I print ypred, now look at here. The first data point belongs to second cluster, first cluster. So let me do one thing. I'll write here data of ypred. Okay, or I can say x of ypred, or I can say cluster. Let me give this name as cluster. Ypred, x of cluster is equal to ypred. And now if I print x, look at here. So the first data point belongs to second cluster, second data point belongs to second cluster again, then third data point belongs to first cluster. So we got the clustering now. We got the data points clustered. Okay. Now we'll plot this and we will see that in a visualization form. So tell me everyone, is that clear till here? Anything that you haven't understood till here? Please confirm this on the chat. Yes or no? Okay, fine, great. Now one more thing, if you want to get the centroid of all the clusters, you can write here km dot cluster underscore centers. It will give you a centroid. So this is the centroid of my first cluster, this is the centroid of the second cluster, and this is the centroid of the third cluster. So here we got the centroid point also. Now let's plot this and let's see. So what I'll do is, to plot we have to split our data, or we can say separate our data into different clusters. So let's say df1 is my cluster 1, data frame 1 is my cluster 1. Now how can I filter the data of only cluster 0? Anybody can tell me? I've already covered this in pandas. So if I have to do this, how can I write here? I want only the data of cluster 0. Only the data of cluster 0. So what should I write here? Tell me. Anyone? We've already covered this before, so I hope you should tell me this. Yeah. Forgot this x of cluster. No. We have to write here x of cluster, x of cluster equal to 0. This is how you filter, if you remember. Explain that. If you write a df1, see, you will get only the data of cluster 0 only. See, I'm getting only 0. No, not ilog. Don't use ilog. We have to use this way. This is how you filter. I want the cluster that is 0 only. Okay. Similarly, you will do it for the other one also. So df2, df3, X of cluster 1, X of cluster 2. So we separated the 3 cluster. And now I can plot. So PLT dot scatter. Let me plot the first cluster. So I'll write here df1 of age, comma, df1 of income. Okay. And let me give the color as, let's say, green, and label as, let's say, cluster 1. Cluster 1. So that's my first cluster plotted. Let me take the size also as 100 so that it will be a bigger point. So I'll change that df2, df3, df2, df3, color, let's say red, let's say blue. Okay, cluster 2, cluster 3. Okay, now if I plot this plt dot show, okay, now tell me, are we getting the correct clustering point? Tell me, are we getting the correct clustering point? Is that properly clustered or not? Tell me, are we getting the correct clusters? No, we are not getting. We are getting some errors. Like here I can see these 2 blue point, it should actually belongs to red, and these 2 also belongs to, like, I can see only 4 points from the blue one. That means blue is not properly clustered. So I'll tell you the reason why we are getting this, but before that, let us draw the centroid also, and let's see where is the centroid. So plt dot scatter, and for plotting the centroid, see, this is your x value for each centroid, and this is your y value for each centroid, right? So I can write here, let's say I'll take a variable here, centroids equal to this, and I can pass here centroid of colon comma 0. That means I want all the x value, all the rows of x value. That means the first column. Similarly, centroid of colon comma 1. That means x and y value I am taking here. Okay. And then x is equal to, let's say, 200. Marker is equal to, let's say, star. I am taking the centroid as a star. And label is equal to centroid. Now if I plot this, just a minute, what is the problem? Oh, here I've given extra. Okay, look at here. So let me change the color of this so that it should be different. Color is equal to, what color should I give here? Let's say purple. Okay, look at here now. Here is one centroid, here is one centroid, here is one centroid. So this is a centroid, I think, for blue, and this is a centroid for red, basically. Okay. So this is what we got here, but this is not proper clustering. Now anybody can tell me why there is an error. Have we taken the wrong k value, or it may be some other reason why we are not getting a proper clustering? Tell me, what can be the reason behind this? And if you have followed my all the session, you should definitely tell me the answer of this. Tell me. 2 cluster. No. I can clearly see that they are separated in 3 data points. So obviously it should be 3 cluster, not 2. Yes, very good. There is no normalization done here. The age and salary are totally different. See, the values, they are very different. There is so much of difference in the values. So scaling should be applied here so that we should get a proper cluster. So let's apply the scaling and let's see after scaling is my clustering improving or not. So what I'll do is I'll scale it after this here. After reading the data, I'm scaling it here out itself. I'll take a new cell here. So from sklearn dot pre-processing import standard scalar. So let's say scalar is equal to, I'll make an object of this and I will pass my data. So data of age equal to scalar dot fit underscore transform, and here we will pass the data of age in double square bracket. So this is my first one, and similarly I'll do it for the income also. That's all. Now after doing this, if I run the code again from beginning, let me run all. Okay. Okay, now tell me, have we got the correct cluster now? So see, you can see the difference after the scaling. We got it now correctly. And we got the centroid point also properly in the center, at least exactly in the center. Okay, so this is how we apply k-means clustering. So I hope it's clear to all of you, everyone. Yeah, okay, fine. Now moving on to the elbow method. How you can use the elbow method to find the appropriate value of k. So let's see, after applying elbow method, are we getting the same k value or we are not getting the same k value? So what I'll do is I'll take a blank list here, sum of squared error. Okay, so for k in range, let's say I'll take the k value from 1 to 20. Let's say you can take maximum k value should be the number of samples. So I'm taking till 20 only, because till 20 I'll get the elbow. So I'll take till 20. Okay, then let's say km is equal to, k means I'll again make the model. So n underscore clusters equal to k. Now km dot fit, and here you'll pass your x value. Okay, you'll pass your x. Wait. In the x we have appended the prediction. Na? So let us pass directly like this: data of age, comma, income. Okay, age, comma, income. Okay, and then we'll append the, and see, to get the sum of squared from the model, we have directly one function which is km dot inertia. It will give you automatically the sum of squared for the clustering, inertia underscore. Okay, so now if you run this, just a minute, km dot inertia is not working. INER, oh sorry. Okay, done. It has done for all the things. Now we'll plot this. So plt dot, let's say x label k value, plt dot y label sse, plt dot plot, and here I will pass on the x-axis I will take the range value of 1 to 20. That means that is simply the k value only, and on the y-axis I will take SSE. Okay, and plt dot show. And let me give the x ticks also. Plt dot x ticks range of 1 to 20. Okay, now if I run this, okay, so look at here where you are getting the elbow. If you see this graph, you are getting actually the elbow on 2 points. Okay, where are the 2 points? One is here and one is here, right? So basically you have to consider that point from where the graph become constant like this, straight line. So we'll consider this one. So you can see that this is 0.3 only. This is 0.3 only. So we have done the correct assumption. Okay. So this is the elbow method. So I hope it's clear to all of you. So this is how we find out the k value, appropriate k value for the k-means clustering. So this is all for the k-means clustering. So I hope it's clear. So can we move on to the hierarchical clustering? All of you present here, hit the like button. Hit the like button, please. Okay, so now let's apply the hierarchical clustering and let's see how to do that. Now I'll discuss only agglomerative because that one only we use, and I'll discuss that only. Okay. So what I'll do is I will take a copy of this file. I'll make a copy of this file. Okay. Because most of the parts are common here. Okay, I'll share the link of this file on the chat. This is giving a problem. Okay, I've given the link on the chat. You can check it. Okay. Now in this one, I'll remove all the code from after this part. After this part, I'll remove every code after this k-means part. Okay. So I kept the code till the splitting of data in the X. Okay. So now I'll run the code from the beginning. Okay, so this is my X data, which is a scaled data. Fine. Now we have to apply hierarchical clustering here. So first of all, we have to plot what? Dendrogram. We'll plot dendrogram first. Okay. So for that, we have a library import scipy dot cluster dot hierarchy. as, let's say, SCH, as SCH. This is a library that we are importing. Now let me make the figure size at as bigger so that we can understand this properly. 10,7. Now I'll make a variable here. Dendrogram is equal to, it's simply a variable. You can take anything. Okay, so dendrogram is equal to SCH dot dendrogram. SCH dot dendrogram. Now here you will pass SCH dot linkage. Through linkage you will pass your data. So SCH dot linkage, and here you will pass your data that you want to plot. So data of, I can pass here directly x. Okay, sc dot x, and then you have to find pass which method you are using for the linkage. Now I told you about different method, single, complete, word, average. So let me apply the single method. Okay, single method. We have another method also. You can try all. Complete. We have complete. We have average. Okay, we have word. We have single. Okay, they are the different types of linkage. Okay, fixed size equal to. Okay, now after doing this, after defining all these dendrogram, now we will plot this. So let me give one thing. plt dot title dendrogram size equal to 15. Okay, and then plt dot. Now let's see. It will take some time because as I told you, this is a time taking process, so it will take some time. Just a minute. Why I got the error here? Oh, sorry. This should be passed inside this linkage function. Yeah, here. Okay. Again, what's the problem? Oh, doing so much of mistake today in spelling. Okay, now it is plotting the dendrogram. Okay, you can see here we got the dendrogram. See. So now tell me which line you will consider here by the dendrogram. Which line you will consider, and how many clustering point you can you will take here. Just tell me how many clustering point you will take here. How many clustering point you will take here? How many clusters? 3. So see, if you consider this line, here it is cutting this point here, like here 1, 2, 3. There are so many points which are cutting here. But if I consider this line as the longest line, it's very much proper, right? This is very much proper. So how many clustering you can see in this, in between this? 1 here, 1 here, and 1 here. But this is the part of one cluster only. So I can see 1 and 2 and 3 cluster. So in between this line, I can see only 3 cluster. Am I right? No, why? How 4, Ritu? This is outside this line. Na? You cannot consider this cluster because this is outside this line. So till here, I have only 3 cluster, right? 1 this, 2 and 3. So 3 cluster I am having here. So I'll consider 3 same. And in the k-means also, we got 3 only. So obviously we will get 3 also here. Okay. So we got 3 cluster here. So now let's apply the hierarchical clustering and let's take the value as 3. So I'll write here from sklearn dot cluster import agglomerative clustering. Now I'll define here cluster is equal to agglomeratic clustering. Now here we have some arguments. The first argument is the number of clusters, which will be 3, which we have decided as 3. Second one is the method, same. And which method we, sorry, not method, linkage. So I'll say that I want to use the minimum linkage, minimum. Okay, minimum linkage. I want to use the minimum linkage. And we have one more argument which you can pass, affinity. Affinity is equal to, let's say I want to use the Euclidean distance to find the distance. Euclidean, I want to use the Euclidean distance. I think spelling is wrong. Euclidean. Okay, I want to use the Euclidean. Okay, Euclidean distance to find the distance. So this is what I have defined here. Okay, so that's what our argument we have defined. Now we'll define our cluster. So let's say I'll take a variable CL is equal to cluster dot fit underscore predict, and here you will pass your X value. So now after doing this, if you print this CL, you will get your cluster. Just a minute. Oh, sorry. Why I have written here minimum? Single, na? Single actually uses a minimum technique. That's why I confuse that. So you have to pass a single. Okay. So we got this clustering now, and now we can merge this. I have closed the previous file. Just a minute. Let me open the previous file so that I can copy that. Okay, so I can use this one now. I can write here X of cluster is equal to CL, and here you will get your clustering point. So we got the clustering point here, and now I can plot using the same code. Now here we don't have the concept of centroid. Okay, so we don't plot centroid. I'll remove this. I'll remove this. Okay, see here, we got the cluster now. Now see, right now I use the single linkage to got this. If I use another linkage, let's see, are we getting any different output? If I'm reading here, let's say a complete. Okay, I'm changing here also complete. Now if I run this code, there will be change in dendrogram. See here. But the data point, the number of clusters will be same in all the dendrogram. You will see exactly the same kind of result. See here, same result we got here. If I use average, you will get also same result. So almost all the linkage will give you almost same result, but in some case it may be different. So you can try different linkage value and you can check your result. So this is how we apply the agglomerative clustering. So tell me, am I clear to all of you? Is this agglomeratic clustering is clear? Yeah. Okay. So this is all for the clustering that I have to discuss. Okay. Now, as we have some time left, getting the number of k values from dendrogram, like, is that your doubt? Okay. Okay. Okay, look at here. There is no application when to use k-means, when to use agglomerative. You can use anyone, but hierarchical agglomerative will take more time. Okay, there is no application of this, something specific application. Okay, now see here, Kevin. Now here, if I draw the horizontal line everywhere, it's not working. Okay, leave it. Let's say here I'm drawing horizontal line, here I'm drawing horizontal line. Like this I'm drawing. Okay, now if you consider this line as the longest line, so if you see here 1 2 3 point, here 1 2 3 point, here 1, no, not this, you not consider this one. Okay, till here only. So we got total 3 points here, 3 points. If I consider this one as the longest line, this one, so in this case also, wait, look at here, 1 2 3 and 4. We got 4 points which are crossing. So like this, if you notice for all the lines, if I consider this line, I will get only 2 points, and that is the minimum number of points where we are cutting. So if I consider this line as my final longest line, if I consider this line as your final longest line, so in between this line, that means in between this range, how many cluster you can see here? See here, there is one cluster here, there is one cluster here, and there is one cluster here. So how many cluster we are having in between that line? Only 3 cluster, right? And that is why I have taken the number of cluster as 3. Am I clear? Okay, that's all. So now as we have some time, so let me explain how exactly this dendrogram is plotted, how it decides which point we should consider, which point we should not consider. Do you want to learn that? I hope everybody want to learn that thing, how this exactly plot the dendrogram. Okay, so let me tell that to you. So I'll use one example, that is a single linkage. I'll use the example of a single linkage. Okay, let me take it from here. Okay, okay. Now for this one, I'll very fastly, I'll just draw one table. Let's say P1, P2, P3, P4, P5. I'm having 5 points. P1, P2, P3, P4, and P5. So I'm having total 5 points. So I have taken here 5 points. That A, B, C, D, and E. 5 points I have taken here. So I have taken here 5 points. Now, as I told you that it follows the distance thing. Okay. According to the distance, it will follow to draw the dendrogram. Okay. So now this here I am going, this is what we call this, what I'm drawing. This is called distance matrix. Distance matrix. Now tell me, if I ask you what is the distance of point 1 from point 1, if I simply ask you, what you will say? What is the distance of point 1 from point 1? So what you will say in that case? You'll definitely say that it is 0, right? It's 0 only, right? Similarly, if I assume, let's see the values that I'm taking here, this is just an assumption, okay? Don't ask me why this is 10, why this is 5. This is just an assumption that I'm doing here. Let's say the distance of point 1 and point 2 is, let's say, 9. The distance of point 1 and point 3 is 3, 6, let's say 11. Now these are the distance of point 1 from all the points. Point 1, 0, point 1 to point 2, 9, point 1 to point 3, 3, point 1 to point 4, 6, and point 1 to point 5, 11. This is a distance value that I have taken here. Similarly, point 2 to point 2, 0. Okay, point 2 to point 1 already we have calculated here, so no need to write here. Okay, so let's say 0, and let's say this is 7, this is 5, and let's say this is 10. Similarly, this will be point 3 to point 3, 0. This is, let's say, 9. This is, let's say, 2. Similarly, let's say 0, and let's say 8, and similarly, let's say 0. This is the distance matrix that I have calculated. Now, first of all, tell me everyone, is this distance matrix clear to all? Mamta, that is hit and trial. That is hit and trial. You can apply different linkage and you can check where you're getting the better one. Okay. But almost they will give the same kind of cluster. Fine. So this is clear. Okay, great. Now, okay. So now I'll draw one graph. Let's say dendrogram only. So should I draw it in the same? Okay, let me draw it here itself. This is my point 1, point 2, point 3, point 4, point 5. That's my point 1. Okay, okay, yeah, okay. Now this line you can ignore. This is not x and y axis. Okay, this is not your x and y axis. Okay, just I'm taking it as a line. Okay. Now here I will take the distance 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've taken the distance here on the this scale. Okay. Now, as I told you that in the agglomerative, initially all the points are considered as what? As the different cluster. Am I right? Initially they are assumed as a different cluster. So right now I assumed here that they belongs to different cluster. Okay. Now we have to check which point we can merge. Which point we can merge. So what you have to do is, from this distance matrix, you have to find out the minimum point, minimum value, except 0. Ignore the 0 one, because 0 we have to ignore. Ignore 0. Other than 0, tell me which is the nearest, which is the least distance here. Tell me what is the least distance from value here. Just tell me. What's the least distance value here? It's 2, right? That is P3 and P5, right? So I can say that P3 and P5 are near to each other. Can I say that? That P3 and P5 are very much near to each other? Yeah. Right? So now why I have considered here the minimum value? Because I am taking the single linkage. In the single linkage, you have to consider the minimum value. In the complete linkage, you have to consider the maximum value. But here initially you have to consider the minimum value in each case, in each of the case. Right now you have to consider minimum value only. So right now let's consider minimum value. So let's 2. So that means P3 and P5 are near to each other. So what I can do is I'll do one thing. Let me remove this. Okay, let me change the sequence so that it will be better to draw the dendrogram. So P3, P5, P2 and P4, let's say. So P3 and P5 are near. Okay, so I will make a dendrogram. And what is the distance here? The distance is 2. So I'll take it up to 2. Up to 2 I will take here. So that's one pair we have made. Okay. Mamta, let me complete this. Your doubt will be cleared. Just focus whatever I'm saying right now. Whatever question is coming in mind, just hold it for some time. Your doubt will be cleared. Okay. So now we got this one cluster merged into two data point merged into a single cluster. So now tell me how many cluster will be left out now? How many cluster will be left out now? Out of 5, how many will be left out now? 4, right? So let's say now that 4 cluster is, let me draw a line here. Okay, I'll draw it here. We have a space. So now the 4, what are the 4 cluster name? The 4 cluster name is P1 and P2. Why it is written like this? P1, P2, P3 and P5 is one cluster, P3 and P5, and then we have P4, right? This is the cluster that we are having. Similarly here also P1, P2, P3 and P5 and P4. So these are my 4 things that we are having here. Okay. So now we have 4 clusters here. Okay. Now let's say again the distance. P1 to P1 again 0, P2 to P2 0, this one 0. So obviously this diagonal value will be 0. So we'll directly write 0 here. Okay. Now the distance of P1 from P2. This is already calculated in the previous one, which is 9. So I'll write here 9 only. This is already calculated. Okay. The distance of P1 and P3, P5 is not calculated, so we'll calculate that. But P1 and P4 is already calculated. And what is that value, P1 and P4? Tell me. It is 6, right? It's 6 here if you see here, right? Then P2 and P4. What is P2 and P4? P2 and P4. P2 and P4, it is 5. So I'll write here 5. Okay. P4, sorry, here 5. P2 and P4 will be 5. Okay. And P3, 5 we will consider that later on. P4 and yeah, that's all. So basically we have to calculate the distance of P1 with P3 and P5 first. So what are the distance that we have to calculate? We have to calculate the distance of P1 with P3 and P5. This is one distance that we have to calculate. That means here. Okay. The second distance that we have to calculate is what? Distance of P2 with P3 and P5. Am I right? And the third one that we have to calculate is what? Tell me. Distance of P4 with P3 and P5. Tell me, these three distance only we have to calculate. Am I right? These three distance only we have to calculate. Tell me. Right? So now, how to calculate this? So as we are using the single linkage, so as I told you that in the single linkage, you have to consider the minimum value. In the complete linkage, you have to consider the maximum value. So now, tell me, if I consider the distance of P1 and P3, tell me the distance of P1 and P3. What is the distance of P1 and P3? And what is the distance of P1 and P5? Because P1 is common to the P1, P3, P1, P5. So what is the distance of P1 and P3 and P1 and P5? So P1 and P3, it's 3, right? And P1 and P5 is 11. Tell me this 3 and 11 is clear to all? 3 and 11 is clear? Is this 3 and 11 clear to all? Okay. Similarly here, P2 distance with P3 and P2 distance with P5. So tell me, what is the distance of P2 with P3? P2 with P3, it is 7. And P2 with P5, it is 10. So 7, 10. Similarly, P4 with P3 and P4 with P5. So P4 with P3. P4 with P3. P4 and P3 is how much? 9. And P3 with P5. P3 and P5, it is 8. That's the distance, right? 9 and 8. So now tell me, in all these three, as I told you that if you are using single linkage, you have to consider the minimum value. So the minimum value is 3 here, the minimum value is 7 here, and the minimum value is 8 here. Am I right? 3, 7, and 8. So this will be your 3. Okay. This will be your 7, and this will be your 8. So we have to consider a minimum value. 3, 7, and 8. Wrong लिखा है. क्या wrong लिखा है मैंने? What is wrong? I don't think 7. No, it is correct. It is correct. It is correct. Ritu, please check it properly. It is correct. Everything is correct. It is wrong. How it is wrong? P4 and P5, right? See, this is the P4 point. This is the P5 point. So what is the distance? It is 8 only, na? How it is wrong? P3 and P5 is 2. So P3 and P5, where we have taken P3 and P5? P3, P5 we have not taken. We don't have to take P3, P5. Okay. So tell me, have you all understood how this distance was calculated here? So now, how it is 8? See what is this 8 here? The 8 is the distance of P4 and P5. So look at here, P4, P5. So it is 8 only, na? Just look at here, this point, 8 only, right? Yeah. So now tell me, which is the least distance here? What is the least distance? Which point is the least one here? Can I say that this one? Right? And what is this point here? P1, P3, P5. That means I can merge P1 point with P3 and P5. And what is the distance? The distance is 3. That means I will take this up to 3. Up to 3. So this is my next iteration. This is my next iteration. So tell me, is this clear to everyone? Yeah? Am I clear of this, everyone? Okay. So now tell me, in the next one, how many cluster we will left out with? We will have left out with three cluster. The first cluster will be P1. Why this is trying to save? Okay. The first cluster will be P1, P3, P5. Then P2 and wait. Let me take it down. Video buffering. Maybe there is a problem of the internet on your side. Please check that. It's not a problem from my side. So P1, P3, P5, P2 and P4. P1, P3, P5, P2 and P4. Okay, this is what we got here. Now this diagonal value will be 0, so we'll then simply pass here 0 because this will be 0, we all know, right? Now the distance of, first of all, that we know, let us fill that value that we already know. Let's fill that value. So P2 distance with P4. What is the distance of P2 with P4? Tell me. P2 with P4. P2 with P4 is 5, right? It is 5. So I'll write here 5. Okay. Now these two values is not known, so we'll calculate these two values. These two values is not known, so we'll calculate these two values. So now let's calculate these two values. So in the first case, what I'm saying, that I want the distance of P2 point with which point? With P1, P3 and P5. This is the first case. And in the second case, I am saying that I want the distance of P4 with P1, P3 and P5. This is my situation, right? So in this case, what is the distance of P2 and P1? Look at here. P2 and P1, P2 and P1, it is 9. So I'll write here 9. Distance of P2 and P3, distance of P2 and P3, it is 7. So I'll write here 7. Distance of P2 and P5, so P2 and P5, it is 10. So it will be 9, 7, 10. Am I correct, everyone? Tell me. 9, 7, 7, 10 is correct? So this is what we got for the first case. For the second case, P4 and P1. P4 and P1. So P1 and P4, 6. So I'll write here 6. P4 and P3. P4 and P3, P4 and P3, it is 9. So I'll write here 9. And P4 and P5, P4 and P5, P4 and P5, it is 8. So I'll write here 8. So 6, 9 and 8. So tell me, if you are taking a single linkage, which value you will consider here? You will consider here 7 and you will consider here 6. That means my value will be 7 here and my value will be 6 here. Am I right? 7 and 6. Correct? So what is the least point here? Now tell me, which one will be clustered now? Which one will be clustered now? Tell me. The least point is this. That means P2 and P4 will be clustered, right? P2 and P4 will be clustered now. So it will cluster now P2 and how it is deleted? And P2 and P4 is having the distance of 5. So we'll go up to 5. So we will go up to 5. So this is the dendrogram that we got for the P2. Okay. Now finally, the last iteration. In the last iteration, what we will left with now? P1, P3, P5, P2, P4, P1, P3, P5, P2, P4. So we are left with only 2 clusters. So this will be 0, this will be 0. That we all know. Okay. Now the same thing will be followed here now. So we'll calculate the distance of P1, P3, P5 from P2, P4. That is only should be calculated. Only one distance should be calculated. So in this case, you will consider P1, P2 distance, P1, P4 distance, P3, P2 distance, P3, P4 distance, then P5, P2 distance, and P5, P4 distance. So total 6 distance we have to cover. So tell me, what is P1, P2? P1, P2. P1, P2, P1, P2 is 9. So let's write here 9. P1, P4. P1, P4 is 6. So I'll write here 6. P3, what is this? P1, P2, P1, P4, P3, P2. This is 2. Okay. So P3 and P2. P3 and P2. It is 7. P3 and P4. P3 and P4 is the P3 and P4 is 9. P5 and P2. P5 and P2. P5 and P2. It is 10. It is 10. And P5 and P4. P5 and P4. P5 and P4 is your 8. 8. So we got the distance of all the points. Now tell me which is the least one here. What is the least one here? 6, right? 6 is the least one. And 6 is the data point for what? P1 and what? P4, right? Oh, wait. Oh, sorry. We have done it wrong. We have to consider 2 now. Wait. I have taken this wrong. Not 6. We have to consider only 4 point. Sorry. It's my mistake. Forgot that this is the last iteration. The last iteration. So it will be P1 with P2, P4, P3 with P2, P4, and P5 with P2, P4. These 3 distance will be calculated. So what is the distance of P1 point with P2 and P4? Now see, P2 and P4 is already calculated here. Where we have calculated. Wait, why this is giving problem? No, I think I have, wait, I'm confused here. No, wait. It was correct. This is already not calculated. We'll consider that only. P1, P2, P1 and P4, P3 and P2, P3 and P4, then P5 and P2, and P5 and P4. Now tell me the distance that we calculated earlier. Anybody has written that? Otherwise I have to check that again. I think this was, let me go to the chat and say that. Nine. Then this was P1 and P4 was P1 and P2 is 9, right? P1 and P4, P1, P3, P5, P2, P4. P1 and P4 is P1 and P4 is 6. Okay, so it is 6, 7, 9, 10 and 8. Yeah, this is what we got here, right? Correct. So basically we got the least distance for P1 and P4. So this is what we got here. Now here we have to fill this value here, correct? So these are distance value that we got here. So the least distance is 6 here, right? So what I'll do is I will fill the value as 6 here, correct? 6. So now we got the distance as 6. Now tell me, here obviously we have only one data point left. So we'll consider this only as the least distance, right? So we'll merge this P2, P4 with P1, P3 and P5. And what is the distance? The distance is 6. So that means this one will be merged till here. So this is your final dendrogram. Okay. No. One by one, you take only two data point, P2, P3 and P2, P5, Mamta. Okay. So this is your final dendrogram. So I hope you understood this, how dendrogram is plotted, how the points are decided, that which point to be clustered and which point should not be clustered. Tell me. I hope you understood this. Yeah. So this was all about the clustering, and I hope you understood that today's session. You enjoyed this today. So that is all for today. Yeah, thank you so much, Sachin. And everyone present here, please hit the like button. Hit the like button, everyone. See, Kevin, there will be very least chance in that case. If there are two minimum values, then you can consider any of the two. Or you can make two dendrogram. There can be two dendrogram also, na? You can merge P1 with P3 like that also. So there can be two dendrogram also. Okay. I'll make this as a PDF and I'll share that to you, okay, in the drive. Now for the tomorrow's session, there will be hardly 1.5 hour, maximum 1.5 hour, 1 or 1.5 hour. Okay. And tomorrow I'll explain the deployment part, how you can make a simple web application and how you can deploy your project to the server so that anyone can use it. So this is what we are going to tell you today, tomorrow. And after that, there will be a quiz for half an hour. There will be hardly 15 to 20 MCQs, okay, which you have to answer. So timing will be for tomorrow. It will be from 6 o'clock. We'll start the session by 6 o'clock, and by 7 o'clock or 7:30, I will start the quiz. Okay. So tomorrow by 6 o'clock, we will have the session, and by 7 or 7:30, we'll start the quiz. And one more thing. I will provide the quiz link. I will provide the quiz link on the chat only. Please do remember this. I will not provide the quiz link in the WhatsApp group. So you have to be in the session to join the quiz. Please don't message me personally later on. Please provide me the link for the quiz. Don't do this. I will not reply for that quiz thing tomorrow. You should be in the session. I will provide the quiz link here on the chat only. So if you miss that link, that is your problem. So you have to be careful here. After providing the quiz link, I will be here for 10 to 15 minutes. Okay. So around 7 to 7:30, in between 7 to 7:30, I will share the quiz link after completing the tomorrow's part. Because I'm not sure whether it will take 1 hour of time to complete or 1.5 hours. So by 7:30 maximum, I'll share the quiz link. Okay. So please don't tell me tomorrow personally that please provide me the quiz link. I'm telling this again and again. Please take this seriously. I will not give the link on the WhatsApp to no one, to anyone. Okay. So I'll provide the link here itself in the class only. And after the providing the link, I will be here for 10 minutes so that everyone can get the link. And in between that time, if you miss the link, I'll provide it here on the chat. Okay. Yeah, Sunil, let me see my schedule. Maybe in the next month, I will do that neural network part. Okay. So now I'll provide the attendance link. So you can go and fill the attendance form. And everyone, please hit the like button before going to that attendance. And one more thing, I would like to tell you about one more thing. Like right now, is the minimum? Yes, 70% of the attendance is required. And at least 60% of the marks should be obtained in the quiz. 60% of the marks. Okay. For getting the certificate. Okay. Now, in this complete 2 weeks, we studied about the machine learning, data cleaning, machine learning algorithm, and so many things we have done. So basically, we have done the part of machine learning algorithms, right? So now, if you want to learn more about some other field of the machine learning, like image processing, web scraping, NLP, that is sentiment analysis, neural network, all these things, if you want to study image processing and all these things, if you want to study, there is one training that is going to start from Monday, and the timing will be from 6 to 9, and I will be taking that training. That will be from Finland Labs. So if you are interested, you can register for that training. Okay, and that is a 2 weeks training, and timing will be from 6 to 9. And it's a paid training. So if you are interested, you can go and register for that and you can enroll. So if you go to this link, I'll provide that link on the chat in the group also. There is a content syllabus link here. So these 2 things are common, which we have done already in this session. But the other things that you will be getting here, like, web scraping, NLP, image processing, face detection, AI, the CNN, ANN, all these things are totally new as compared to this link. So if you are interested for that, this link, you can register for this. Okay. So I'll provide the link on the chat, and I'll provide the link in the WhatsApp group also. You can go through that, and if you're interested, you can enroll. Okay. Fine. Vishal, make it 6 o'clock only. That will, because I don't want to be late after the quiz. So everyone, just tell me how many of you are having a problem with the timing on 6 o'clock. Just give me a thumbs up on the chat, those who are having a problem with 6 o'clock. Otherwise, I will give the timing at same 7 o'clock only. Okay, you have already attended that session, Prakash. Okay, great. Okay, Rajesh is having a problem with the timing. Okay, fine. So we will have the same timing, 7 o'clock only. Okay, fine, no problem. We will start the session at 7 o'clock, and by 8 o'clock, 8 or 8:30, I'll provide the quiz link. Okay, fine. Because many of the participant is having the problem with the time. So, okay, we'll keep the timing as it is. Fine. Fine. So go through that link, and if you're interested, please enroll in that. I will only take that session, and it is going to start from Monday. Okay. Yeah, Prakash, thank you for recommending that course. Thank you so much. PDF file link. Okay. Which PDF you're asking? Which PDF you're asking, Hasina? If we get the same answer. Mamta, for which one you are asking? Same answer means? Tomorrow by 8 or 8:30 we will have the quiz. Okay. Yeah, these video sessions will be available on my channel for lifetime. Okay. It will be available here. No, for the coming program, it will not be available. It's a paid training, so it is not available on YouTube. But the recording will be provided separately. Not on YouTube, it will be on GoToMeeting or Zoom class. So it will be there. Okay, fine. Finland course PDF. Okay. This is the PDF link of the course. You can go through this. Okay. Fine. So tomorrow, 7 o'clock, we will have the session. And by 8 or 8:30, I'll start the quiz. Okay. Fine. So now I'll provide the attendance form. So before going to fill the attendance form, please make sure that you hit the like button and subscribe to my channel if you have not done, because this is only the small support that I want from your side. It motivates me to bring more free sessions for you on my channel. So please do share my channel and videos to your friends and colleagues and tell them to view my channel and explore my channel. Okay. So this is the attendance form link I'm giving on the chat. And I hope you all have joined the Telegram channel that is in the description, because all the updates will be given on a Telegram channel regarding any new training. Okay. So please do join that. Sunil, I cannot provide the recording like this. That is not company-based training. So you have to participate in that training to get the recording. Okay. Will you include classification of image data? Yes, Pradeep. Yes, the image data will be included in the CNN in the upcoming training. Yes. Yeah, Smita, I will share this link in the WhatsApp group after some time. You can get it from there. Okay. Jonali, I'll see. Right now it is not possible. Maybe next week or maybe next month, or we will plan that. Okay. But if you're interested now, you can join that course. It is there in that course. Okay. Kevin, are you asking for this training that we are going right now? Yeah, it will be from an organization. It will be from an organization only. Okay. Just check the pinned message, Sak Resma. I have given the attendance link. Check the pinned message, or I give it again. Take it. And in the description of the video, you will get my Facebook link, Facebook page link, and LinkedIn link. You can join me. You can connect me on LinkedIn and like my Facebook page also. Okay. Fine. So I hope you all enjoyed today's session. So now I'll take a leave and we'll wind up now. So thank you so much everyone for joining this session today. I'll see you tomorrow for the last day of our training and at 7 o'clock at the same timing. So take care everyone, stay safe and bye everyone. Bye.